Thermal conductivity testing is often most straightforward when working with solid materials. Their fixed shape and stable structure makes it easier to position sensors and maintain consistent contact during measurements. But many real-world materials aren't solid. Liquids, powders, gels, and other non-solid samples behave very differently, and that introduces additional challenges. These materials can shift, settle, evaporate, or contain air gaps during testing. They may also require containment to maintain proper sensor contact. Without proper preparation, these effects can distort heat flow and lead to inaccurate or unstable measurements. That's why non-solid samples require careful handling and controlled testing conditions. Unlike solids, non-solid materials don't maintain a fixed structure. Several physical processes can then influence their behavior during testing. Evaporation can reduce sample volume and change composition over time, which directly affects thermal properties. Suspended particles may settle, creating non-uniform sample and affecting how representative the measurement is. In powders, differences in particle arrangement change the amount of airspace, and that strongly impacts measured thermal conductivity. And because these materials require containers, the container itself can influence heat transfer if the sample isn't properly prepared. When testing liquids and gels, controlling the sample environment is critical. To reduce evaporation, samples are typically tested in sealed containers. Degassing can help remove trapped air that would otherwise affect heat transfer. Liquids can also develop natural convection when temperature gradients are present. This fluid motion can increase the apparent thermal conductivity if not controlled. Measurements should be performed once the sample has reached thermal equilibrium to avoid unstable heat transfer conditions. Low viscosity fluids may leak or be displaced during testing. Some systems use controlled pressure to maintain a stable sample volume. The sample must fully surround the sensor. If the volume is too low, the sensor may be exposed to air or influenced by the container walls, introducing measurement errors. Powders introduce another key challenge due to air-filled voids between the particles. These voids strongly affect thermal conductivity, making packing consistency essential. To improve repeatability, fill the sample gradually, gently tap to settle the material, level the surface, apply a consistent compression weight if available. Even small differences in packing can change bulk density and significantly affect results. Small inconsistencies can lead to major errors. Common issues include inconsistent sample volume, inconsistent packing methods, air bubbles or voids, disturbing the sample after preparation. Even minor changes like reinserting a probe can alter the sample structure and impact your results. Testing non-solid materials requires more than just the right instrument. It requires careful preparation and control. Liquids, powders, and gels can shift, settle, evaporate, and trap air, all of which influence measurement accuracy. By maintaining consistent sample volume, using repeatable packing methods, minimizing air entrapment, and ensuring proper containment, you can significantly improve reliability. With the right approach, accurate and repeatable thermal conductivity measurements are possible, even for the most challenging of sample types.